So we have only 2 more sections from chapter 3, 3.5 optimization and 3.7 anti-derivative. So my plan for today is to finish those 2 sections. They're short, not too long. So I believe we'll be able to finish them today. And then next week, Monday, I have a conference. I cannot be here as I started class online, but actually the class will not be online. Instead, like last time, I'm going to give you a lecture recording, which I already posted on Brightspace. So watch that recording. It's for 1 hour or something. Watch that recording. Whatever you don't understand, we'll go over that on Wednesday. And on Wednesday, we'll have in-person class. Then this is the schedule for next week. After next week, the following week, we have it off, spring break. So for 1 week, we'll not see each other, and then we'll be back again after 2 weeks. Okay? Any question, comments? Raka?
So the last class, we have our final exam, and the week before last class is our third.
Let's see. What do I have in the syllabus? Our exam 3 supposed to be on May 7, which is 1 week before the last class. And usually we have final exam after last day of class. But if you guys don't want to come back, I can have the final exam on the last day of class. I think last day of class giving the final is best. We don't have to come back again. I don't even know when the final exam scheduled for our class, but we can have it on our last class on May 14. And then our exam will be on May 7. So I have 1 week to grade the exam. Yeah, not bad. Any other question? So, okay, so May 7, I highlighted yellow, supposed to be online, but it will not be online. It will be asynchronous, like you're going to watch your recording on your own time. And then we'll be back again on 9th, Wednesday. We'll discuss everything, whatever we did not understand from the lecture. And then we have 2 classes, no class. And then we have 1, 2, 3, 4, 5 class, 1 lecture, 1 review, 1 final. Any question? We are really near the end. So what is your reflection about this class? What do you think about this class? Are you guys enjoying or getting tired? Kind of getting tired, right? But I'm actually happy to grade your second exam. I was expecting to be bad, but most of you actually did good. But a few of you did good in the first exam, did bad in the second one. And a few of you did bad in the first exam, did very well in the second exam. So I see a flipped version of you, which is good and bad at the same time, but overall it wasn't bad. So our third exam will start from optimization. And optimization is kind of a hard topic, but I'm not going to do much example here. We have many real life example here. What we learn in optimization is we want to use calculus to maximize or minimize anything. Okay, that is our purpose. Optimization means what optimize something. How can we get maximum of something or minimum of something? We don't look in the middle, we only look at either the highest one or the lowest one. So this is real life example, just like related rate. The difference between related rate and optimization is in related rate, we work to derivative respect to time, and we see when 2 things or more things are changing respect to time, how other things are changing. And here we don't look at change only, we look at how can you maximize something or minimize something. For example, when you run a business, you want to see how can you get maximum profit, right? That's what we look for. Or when you buy something, you want to see how can you spend minimum amount of money. This is a real life scenario. So that's when we use optimization. And we don't have to use calculus, but for many cases, if you use calculus, makes your life easier. How to use calculus is that, when you find maximum and minimum of anything using calculus? How do you know?
Take the first derivative and say equal to 0.
Exactly. That's all you have to do. Take the first derivative, set it equals to 0. That will tell you when you have maximum or minimum or something. So how do you solve this type of equation or this type of problem? First thing, you understand the problem. If you don't understand by reading it first time, you read it. Keep reading again and again and again until you understand what is given and what they want you to maximize or minimize. Then, if possible, draw a diagram. Sometimes drawing diagram helps. For example, the balloon example, or not the balloon example, the cone example we did in class. If you draw the diagram, you can see clearly what is happening, which things are changing respect to which one. So drawing diagram helps if you know how to draw. If you don't know, forget it. And then introduce the notation. What variable you want to use for given and for what you're looking for. Once you have a notation, express the quantity to be optimized in type of one variable. For example, let's say you want to see like the cone example, we have height and radius at the same time. So you have two variables. One variable is for radius, one variable is for height. But we cannot work with two variables. So if you have two variables, always convert one variable in terms of the other variable. So whatever you're optimizing, convert that into that variable. Find the domain and maximum minimum of the quantity. We actually don't look at the domain much because we don't care about domain much when you solve them. But in reality, if you look at the domain, if you don't look at the domain and you get some result that doesn't fall inside the domain, we cannot accept those. For example, time. What's the domain for time? 0 to infinity. So if you have a negative time after solving an equation, do you accept that? No. So we don't look at domain directly, but we look at domain contextualized. Like we connect the information with the real life and we see the domain automatically. And that answers the question, whatever they ask for, does it make sense? Did you answer it clearly? So these are the steps for optimizing. Once you know all these steps, then you are ready to solve them. Here I have all the details of what each step is supposed to do in each step, but I'm going to skip all of these because I already told you all the details. Now let's do one fun example. Find two positive numbers whose product is 16 and whose sum is minimum. Oops. Oh man. Let's see the didn't answer, okay? So two numbers, when you multiply them, the result is 16. And when you add them, you want the smallest sum. For 16, the number is too small, so we don't even need the calculus to solve it. It can do it by algebra. For example, 16, when you multiply the two products are the two factors are either 116, 28, or 44, right? We want to see which of these gives us smallest possible sum. So if we add this, we get 8. If we add this, 10. If we add this, we get 17. So which pair gives us the smallest sum? 4, 4. We don't need the calculus to solve this. But let's see if you use calculus. How would you solve it? So we start with by assigning the two numbers. I'm not going to give you this example. So yes, I expected to use calculus, the derivative. I started with this one because this is fun example. Okay, so we start by assigning a variable. Let's say x is one number, and let's say y is the second number. And then what do you do? How do we utilize the information they gave us? Great. We start by the information they gave us. X times y is 16. We have two variables. We cannot work with two variables. We want one variable. So what can we do? Solve for one variable. Either solve for x or solve for y, it doesn't matter. Let's say I'm solving for y. So divide both sides by x. We get y equals 16 over x. In other words, 16 times x to the negative 1. So we use the first sentence to make one equation, and then we solved one variable from that equation. What is our next step? How do you interpret the second sentence? Whose sum is minimized? So where do you start for this sentence? What is sum? So we want to minimize the sum. So our sum is x plus y. We have two variables again. So what do you do? We cannot solve one because we don't have the other side of the equal sign. But what can we do instead of solving? The answer is in front of you. If you don't want to see two variables, what can you do so they become one variable? You substitute. Substitution. See, your y is this. So let's replace y with whatever we have in terms of x. So our sum is x plus 16 x to the minus 1. And now we are happy. The thing we are optimizing, it has only one variable. How do you optimize anything? Using calculus, what do? Take the derivative. So derivative of the sum, let's say sum prime. And then what is the derivative? Actually, let me write the step. To optimize the sum, take the dx of both sides. We are taking the derivative with respect to x, ddx. So derivative of the sum is derivative of the sum. And what is the derivative of x? 1. What is the derivative of 6 times x to the negative 1? Negative 16 x to the negative 2 power. In other words, we have 1 minus 16 over x squared. So we took the derivative, but we didn't optimize, right? How do you optimize this derivative? Right? It equals to 0. And solve for x. So step 1, whatever information we have, use that to make equation. Step 2, from that equation, solve for one variable. Step 3, whatever you're optimizing, make an equation for that. Step 4, replace one variable in terms of other variables. And then step 5, take the derivative. And last step, set it equals 0 to solve for the variable. So to solve for x here, now you're doing algebra. What algebra told us to do here? -1, -1. So we have -16 x squared equals -1. Multiply by, let's say, negative x squared, because we don't want the negatives, right? So multiply by negative x squared on both sides. So negative turns into positive, x squared cancel out. We have 16 in one side, and what do you want on the other side? X squared. But we're not looking for x squared, we're looking for x. What do we do? Square root. So we get x equals 4 and -4. Do we take both answers? Which one you cannot take? Why not? Great observation. It says 2 positive number. That means we're only allowed to take x equals 4, not -4. So we get one number is 4. That means the other number is also 4. It's 16 over 4. That gives us 4. So the two numbers you look for are 4 and 4, which we already knew without even doing calculus from our algebra. But that's how we do optimization. Our main goal here is to do something to make an equation that we can use the derivative, and then we set it equals to 0 to solve for the variable. Any question? So does optimization sound hard to you guys? Or you think it's okay? Let's see what is our next example. Something about real life money. Let's say to produce X units, the cost is given by this function. And the demand function, which is another name, the price function, is given by the P function. They give us the cost function and the demand function. What price will maximize the profit? So you are producing something to sell something. Your goal is to see how many units, what the price value is supposed to set for each unit. That will give you the maximum profit. Let's say you're producing video games, and you know your cost for producing that and the demand or the selling price, the price of that CD supplies. You want to know how much cost you're supposed to put for one CD so that at the end you get maximum money you get back. Did you understand the scenario? Great. Question number 1, profit. Oh man, I give you the answer. Actually, I have done that. How do you find profit? Revenue minus cost. They gave us the cost, so we are happy with the cost. Did they give us the revenue? Instead, they gave us demand. So what is revenue? X times demand. So in other words, it's X times price. X is number of quantity we have, and price means price for each quantity. So revenue means how much money you get after selling something. So we get the revenue by multiply number of units you're selling times cost for each item. So that's how we get the revenue. But if they did not give you the price, we use demand function to get the revenue. So we start by finding the revenue because revenue gives us the profit. So revenue is X times demand. That means we have X times 30 minus 0.1X. That gives us 30X minus 0.1 X squared. And now you're happy. We have the revenue function, we have the cost function. We can go ahead and find the profit. What is profit again? What minus what? Revenue minus cost. And you have to remember all these formulas. In the exam, I'm not going to give you these formulas. I gave you the information here because you're doing it for the first time. So we have a revenue function, 30x minus 0.1x squared. And we're subtracting our cost function. Anytime you subtract more than one quantity, either you put a parenthesis or you have to change the sign when you replace. So we have 20x plus 80 for cost. That gives us our price profit. That gives us our profit is 30x minus 0.1x squared minus 20x minus 80. So negative 0.1x squared. How many x's we have? Positive or negative? Positive. Positive 10x minus 80. Any questions so far? Are you guys understanding what we are doing? What is revenue? Number of items times price per items. What is demand? It's the price for the selling items. So actually the number of item and demand is like price for your items. So, so if they give you the price function, it's X cents price. But if they give you the price, at least they give you the price for each item, then you can find it. But if they did not give you either the price function or the money price, instead they give you the demand, then it's X times demand. Any other question? What we are maximizing? Profit. So we have our profit function. How can you maximize it? Great. To maximize the profit, you take the derivative of the profit, so that equals to 0, solve for items. So let me write it down. To maximize the profit, set d dx of profit equals 0. D dx of profit equals 0. Solve for x, which is the number of items. The derivative of the profit is, let's say, profit prime. What is the derivative of the entire function? Plus 10. We set it equals 0. And then how do we solve? Go ahead, Apollo. No one wants to participate. You can minus 10, or actually you can add 0.2. In that way, you have only one step to do. You can add the 0.2x to both sides. So 10 equals 0.2x. It divide by 0.2. Dividing by 0.2 means multiplying by 10/2. We get 50. If you want to know manually what I did this. 10 divided by 0.2 means 10 divided by 2/10, which is 10 times 10/2, which is 10 times 5. You're going to use calculator anyway, so if you don't want to know, you don't have to know. But knowing it manually actually helps. Why it doesn't stay? So x is 50. What is x again? What x represents? What are you looking for?
Price of which?
The price. We know 50 items going 50. If you sell 50 items, you're going to get the maximum profit. But do you know what is the maximum profit? Sorry, not the maximum profit. Do you know what price you're supposed to set to have that maximum profit? Not yet, right? What can you do so that you can know the price for your each item? Not each item, actually. The price for, price for 50 items. Is it price for 50 items or price for one item?
Multiplied by X.
It's supposed to be one item. If you do it for 50 items, our price function, it's for one item, right? The demand function, so we know 50 items going to give us the maximum profit, but we are not looking for profit. We are looking for the price. What price we supposed to set for these 50 items? Yeah. So we have the price function, which is a demand function, is 30 minus 0.1x. So 30 minus 0.1 times 50. Do you know what is 0.1 times 50 is? Let's do the math here. 50 times 0.1 means 50 times 1/10. 0, 0 cancel out. We get 5. Oh, definitely not price for 30 items, right? It's price for one item.
Multiplied by X beforehand, right?
To get the profit, yeah. So it's $25. There's no way you can set $25 for 50 items. It's equal. So one item going to give you 25. If you set $25 for one item, then you can have your maximum profit. They didn't ask for what is the maximum profit. They asked for what is the maximum, what is the price to get the maximum profit. So this is our answer. Logan.
So the band before the first one.
Who is lost? Anybody? Nah. So the first question we did was something with math, fun. The second function we did something related to real life, the money problem. And now we are going to do the third type of function as a constructor or something like that. Oh, before we move on, does anybody have any question on the second question? Any question on the second problem? No question, nothing? Raka?
Wait, so $25 price of one item or
One item. But it does sound like it's priced for 50 items because we replace into the price function. But if you set $25 for 50 items, that means $1 for 2 items. How can you get maximum profit? It doesn't seem right. The next one. A box with square base and open top have a volume of 13,500 centimeter cube. So the box has a volume of this much. Find the dimension of the box that minimize the amount of material used. Who understood this question? But you are minimizing what? They give you the volume, but you're not minimizing the volume. You are minimizing all the sides, right? So what type of equation we get if you consider all the sides? Good job. From all the sides, we get the information about surface area. So in other words, we are actually trying to minimize the surface area. So this is the story. We have a box with the bottom is a square. And there is no top. We are leaving the top open. So the base here, the green base, it has area of the base is x squared, right? Because it's a square. And we have 4 sides of the box. Each side has a base x. And how about the height? Did they give us any information about the height? So what variable we use for height? H. So we have 4 sides, and each side has length h and width x. So we have 4 sides with area 4 times area for each side. So what is the area for this side? We have the same area 4 times. So what is the area of one side? It's what? XH. It's length times height. We have one side is length times height, which is h times x. And we have the same side 4 times. So it's 4 times this area. And you have only one base, which is a square. So area of that base is x squared. Now, why do we care? We care because what is surface area? It's the area of each side. So if you look at surface area, what formula we have for the surface area here? Ellen. 4xh plus x squared. 4xh is the area of 4 sides. X squared is the area of the base. Why do we care? Because that's the surface area, the area of each side. and you're minimizing that. But we have a problem, right? How many variables we have in our surface area formula? 2. When you have 2 variables, we cannot find the derivative. So we go and take the help of the volume. In general, what is the volume of a cube? Length times width times height, right? So what do we have for the volume for this specific box? What is our length, width, and height? We have x, h, that gives us x squared h. So let me erase my surface area for now. I'll write it later. And we know our volume is 135,100 is x squared h. What can we do with this information? We can solve for h because we need to get one variable from 2 variables. If you solve for h, we get our height is 135,100 over x squared. And now if you look at the surface area, we are not going to have the 2 variables issue anymore. We had x squared plus 4xh, which is same as x squared plus 4x, 135, oh, I have more zeros, over x squared. We can cancel one of the x's. We get the surface area is x squared plus 4 times that divided by x. Five four zero zero zero. But this is same as x squared plus 54000 x to the negative 1. And now you're very happy because you can find the derivative of this function easily. Since you're minimizing the surface area, what do you have to do? Take the derivative. So derivative of the surface area is derivative of the surface area or surface area prime, whatever you want to say. What's the derivative of x squared? 2x. What's the derivative of the second term? -2, that gives us 2x, 54,000 over x squared. So we have our derivative. Sorry, not holding the F thing, my bad. And how do we minimize this? Set equals to 0. So we have 2x equals 54,000 over x squared. Now algebra, what do we do? Multiply both sides by x squared. So they cancel out. We have 2x cubed is 54,000. Divide by 2 gives us x cubed is 27. How do you find x then? Cube root. We apply the cube root on both sides. It means what number when you multiply 3 times turns into 27,000? Which number? Are we done? What is the question they're asking? Find what? Find the dimension, right? Did you find all the sides? So we found 2 sides because we have the same sides twice. How about the other side? What we did not find? H. How do we find H? Where? So we have 13500 over 30 square, 13500 over 900. 2 zeros cancel out. That tells us what is our H? 15. And now we are done. We found our X, we found our height. So if you create a box 30 by 30 by 15, then you can use the lowest amount of materials possible. With this, I'm done with introducing you to the optimization. So your homework has many other scenarios, but that's all you have to do. Create equations, 2 equations. One you're optimizing, and the other one you're using to convert one variable in terms of another variable. And then you take the derivative of the function, what you're optimizing, set it equals 0, solve for the variable. That's it. Any question? Find the dimension that minimize the materials you used to create it. Any question from anyone? Any comments? Complain? Nothing? Okay, then. There are 2 questions. I'll give you 10 minutes. Okay? 2 questions, 10 minutes, and then we are going to do antiderivative, which is a fun section. Let me take your attendance now. Oh, that was a different.